Okay, so this problem says we have 13 black and 6 white hexagonal tiles we used to create the finger below. Okay, so let's say black we have 13, like here we have 12 plus 1, the white we have 6. Okay, so if a new figure is created by attaching a board of white tile the same size and shape as others. So let's say we will put like white here, like this, attached like this, white. So the question is, what will be the difference between the total number white and the total number of black? So we want to find the total number of white minus number of black. Okay, so we just want to find how many white tiles in the outside. So here we have like 1, 2, right? 1, 2. So here 1, 2, 1, 2. Yeah, 1, 2, 1, 2, 1, 2. So we have 6. Then plus this one. So this, like here, right? So we have so this equal 12 plus 6. So the solid ray, the outside ray, we should have 18 white tiles. Okay. So totally, how many white hexagonal tiles? We have 18 plus 6. Yeah. So minus black 13, right? So we have 11 difference. Yeah, 11. Okay. This diagram represents a 7 by 7 floor that tied with 1 square foot black tile and white tile. Okay. Okay. So the corners are just okay, white, black, white, black, white, black, like that. So we want to find how about 15 by 15. Okay, so we can say this 15 by 15 can be 7, like 7 and another 7, like 7, 7, 1, right? So actually we can regard this is formula by this way. Okay. So here is just 7 by 7, 7 by 7, 7 by 7. Okay, so we find this one all is black, and this is black. So from here we also can see like here's black, right? And for this square, black. So outside white, we can understand this way. So we can find a pattern like this way. Okay. So now what is the question? We want to find how many white tile will be needed. Okay. So how many white tile for this 15 by 15? So here 7 by 7, so that's just equal 4 multiply this. So this is 7 by 7, right? So for 7 by 7, we have how many? We have 16, right? So 15 by 15, we have 4 times 16. Okay. So for this problem, what number is directly above 142 in this array of numbers? So we find this array is 1, first one 1. Then we put 3 numbers, 2, 3, 4. Then put 5 numbers, like then 5, 6, 7, 8, 9, like that. So the question is, we have this number, like, okay, so 142, then what is this number directly above this 142? So like for 7, so above number is 3, right? For 8, above number is 4. So at the first we just check those numbers, like 1, 4, 9. Okay, so we find this is square. So 1 square, 2 square, 3 square. So let's say, so let's check, let's say, so 142 is in which row? In which row? So we just check, how about 12 square? 12 square is what? 12 times 12. 144. Okay, so we say this equal, so 142 is, this number is 144. Then 143, 142. So this is actually the row of 12. Then here is 11. So here there's 11 square, 121. And then this is 120, right? Okay, so we know the number directly above 142 is 120. Okay, so for this problem, it says an equilateral triangle is originally painted black. Then each time the triangle is changed, the middle force of each black turn white. So we also can say, like, we also can understand, like, we have the triangle, then cut it, then cut, right? So here we just cut this part, cut this 1/4. Then for each one we cut 1/4, 1/4, like 1/4, like that. Then continue cut 1/4, 1/4, 1/4, just like that. So after some change, after 5 change, how much, what fractional part still remaining? So here we just find the padding. Let's say, so suppose the first one is 1, second one is just 1 minus 1/4, so equal 3/4, right? Then third one is we say 3/4. Okay, so 3/4, so still need, okay, so here we check, like, okay, we have this 3 small one, so this one is, let's say, so we have so for, let's say, for each one, so just still need, okay, yeah, just multiply 1 minus 1/4. Right? Or we can say this, we also can use this way, like equal this one minus, let's say, this one, okay, this one, 3/4, so minus So let's say we have 3 of them, right? We just have by now we have 3 of them. So each one, 3 of them. Oh, okay, we can understand this way. Like we have 3 of them. Each one is 1/4. So we have 3 of them. Each one is 1/4. So we have 3 of them, right? So for we just say for this one, 3 1/4, 3, yeah. Okay. Okay. So for this one, we still need 1 minus 1/4. Okay. Like for each one, for this one, so this is 1/4, like just 1/4, then multiply 1/1 minus 1/4, just cut 1/4. So this equal, we say this equal actually 3/4 square, right? Okay, so we find the way, like changing 1, so we get this, so changing 0, we also can say start from this 0, then after 1 change, 1, after 2 change, 2, so after 5 change, so this equal this 5. Okay. Okay, so let's check some also the problem. So easy one, I just leave this for. Let's check some examples. So for this one, on her first day, solved 1. Second day 2, solved 3. So just 1, 3, and on the day 3 is the 5. So we know on each succeeding day he solved 2 more. Oh, so we know this, we get this such a sequence. Okay. So what is the question? So how many total had this guy solved after working 10 or 20 days? So this problem just like suppose this is A1, so this is A20, so we need to find A is equal A1 plus A2 plus A20, right? So such a problem is just A1 plus A20 multiply in 20, so divided by 2 is 10. So A1 equal 1, so we just need to find A20. Yeah, so such a problem just we need to find what is A20. Okay. So A20, so we say here, so A20 minus A1 equal 19 times D. So D here is 2. So A20 equal A1 is 1 plus 19 times 2. So the A, right? So 39. Okay. So 39, oh, so there's a problem just equal 40 multiplied 10, so 400. Okay, so let's check this problem. Suppose there is a special key on a calculator, so that replace the number x with the number given by the formula. Okay, so this means that x will become thus 1/1 x. If you push 1, so this the change is like this. For example, if x equals 2, so 2 will change to, let's say, 1 minus 2, right? Become negative 1, right? Yeah. So if we calculate the display with 2, then if we push this key, then we get a negative 1. Okay. Now, suppose that we calculate the display 5, then we just press 100 times. What the number become? So we just try find a sequence. The first one is 5, then it will become 1 minus 5, right? So equal negative 1 over 4. So then this will become 1 minus x. So x is negative 1 over 4. So this equal what? This equal 1. So 1 plus 1 over 4, right? So this equal 4 over 5. Then let's check again. So then if this you push this become, let's say, 1 minus 4 over 5. So this equal, go back to 5, right? Okay, so we can say this will repeat. So we need to find period. After how many times repeat? We say period equal. So from here to here 1, right? 1. So to here 2. Let's say 1 push 1. Then push again. So we found the period is equal to 2, right? Push 2 times, it will become the same number. 5 become 5. Okay, so push 100 times, so this just become the same number 5, right? So repeat. Okay. Okay, so we can stop here. So we finish the chapter 3, chapter 5. Sorry, chapter 5 sequence.